Alright, before we start these notes, let me go over a couple of things we talked about in the past. We've talked about all students take calculus, and this was just a way for you to remember in what quadrants, first, second, third, fourth, what quadrants, which trig functions were positive. So in quadrant 1, all trig functions are positive. In quadrant 2, sine and cosecant are positive. So the S stands for sine, but if sine is positive, the reciprocal is also positive. So this says that sine only is positive, so therefore cosine would be negative, secant would be negative, tangent would be negative, and cotangent would be negative. All right, going on in quadrant 3, tangent and cotangent are positive, the other 4 are negative. And in quadrant 4, cosine and secant are negative, positive, so the others would be negative. All right, so in example 1, it tells us that if sine of A is equal to half and cosine of A is greater than 0, and tangent of B is 3/4 and sine of B is less than 0, find the exact value of sine A minus B. Well, the first step you want to do is go ahead and draw those two triangles. So let's first draw angle A. Now, when you draw these triangles, it is important to satisfy the quadrant that you're in. So first, if sine of A is half, since half is a positive number, then I could also say sine of A is greater than 0. So we know sine is greater than 0, cosine is also greater than 0. So they're both positive only in quadrant 1. So angle A is going to be in quadrant 1. So if I draw quadrant 1 and I make an angle such that it's equal to ratio 1 over 2. Okay, now this actually happens to be a special right triangle. We know that this would be 30 degrees. It's not really the point right now, but I mean, we do know that, so that's good to know. And I could go ahead and fill in that this would be root 3. All right, now angle B. So go through all of that with angle B. So it tells us that tangent is 3/4. Tangent of B is 3/4. So 3/4 is a positive number. So tangent of B is positive. But sine of B is negative. So tangent is positive only in quadrant 1 and in quadrant 3. But in quadrant 1, sine would also be positive. So I'm not in quadrant 1. I must be over here in quadrant 3. So this is going to be in quadrant 3. So it's important that you satisfy both givens. It will give you both of these things because otherwise you wouldn't be able to know which quadrant it is in. If it only told you tangent of B is 3/4, you wouldn't be able to conclude if it's in quadrant 1 or 3. So by telling you that sine is negative, that happens in quadrant 3. All right. Now tangent is opposite over adjacent. So the opposite is 3, and the adjacent is 4. And I know that this is down and left, so that's -3 and -4. Now this is a little bit different than the other example, because in the other example, we just recognized 1 and 2, and we knew that it was a 30, 60, 90. Now we know 30, 60, 90s, we know 45, 45, 90s. Angle B is this angle. Remember, it's always the reference angle, it's always the standard angle, not the reference angle. So let me say that again. Your angle is always the standard angle, the entire angle that it represents. But we don't actually know what that standard angle is. So this just represents what B is. We don't know the answer to it. We can just draw the picture for angle B. Due to Pythagorean theorem, though, we can go ahead and fill out what the hypotenuse is. So the hypotenuse is going to be -3 squared plus -4 squared equals c squared. So that's 9 plus 16, which is 25, which is 5. And perhaps you just recognize 3, 4, 5, and if you did that, that's fine too. All right. So that's just your step one, is to be able to draw the triangles. After you draw the triangles, you want to evaluate what it is that it's asking you to evaluate. So it's like asking you to evaluate sine of A minus B. Well, if we match this up to our sum and difference rule, our sum and difference rule is sine A times cosine B minus sine B cosine A. All right, so I don't have the formula chart in front of me. I know that this is correct, but what I'm unsure of is if these two things are switched on your formula chart. So if you take a look at your formula chart, now if you think about it, does it really matter if these two things are switched? If they're being multiplied, does it matter if you multiply this first and this second, or this second and this first? It really doesn't matter. So if these two things are switched, it's just how, this is how I've memorized it. You don't ever have to memorize it, but so just a forewarning, if I have switched these, it really doesn't matter, but you just match it up to your formula chart, and this is what it's going to be. All right, so sine of A, so we go to the A triangle. So we go to the A triangle, and sine of A is equal to opposite over hypotenuse. So that's 1/2. Cosine of B, so now it tells us to go to the B triangle, so that's this triangle, and cosine is adjacent over hypotenuse. So -4 over 5. Then I have this minus sign. Sine of B is equal to, so now I go to the B triangle again, and sine is opposite over hypotenuse, so -3 over 5, and cosine of A is √3 over 2. All right, so in my next step, I multiply this, and I multiply this. So that's what I mean when I say it doesn't really matter if you switch these, because when you multiply these, it'll work out just the same way. All right, so when we multiply 1 times -4, we get -4. And 2 times 5 is 10. -3 times √3 is -3 √3 over 10. Okay, and now we add, because we're trying to simplify here. Now, a lot of people would go ahead and do reduce this fraction, but I want you to think about what would happen if you reduce this fraction. If you reduce this fraction right now, you'd get 2 over 5, -2 over 5. If you had 2 over 5, would you be able to add across the top? And so the answer to that is no, because you wouldn't have a common denominator. So that would be something that kind of takes some practice to know when you should simplify and not. Typically, you don't want to simplify until the very end of a problem, because otherwise you might end up having to simplify again later. But anyway, so the only thing that's really going to change, since I've already got a common denominator, I can go ahead and add across the top. It's actually subtracting, but subtraction is the addition of a negative number. So when I do this, I get minus negative, which is going to change to plus. So we have -4 plus 3 √3 all over 10. And that's it for example 1. Now, how I know that I can't simplify anymore, you can only simplify, you can only divide by 10 if every piece divides by 10. So both of these numbers don't divide by 10. So that is as simplified as it gets. All right, so let's find the exact value of sine 15 degrees. So exact values, those were your 30, 60, 90s, 45, 45, 90s. But of course, if you look at the number 15, 15 is not 30 degrees, nor 60 degrees, nor 90 degrees, nor is it 45, 45, or 90. However, 15 can be the combination of two of these numbers, and that's what we're doing, is we're basically combining. So 60 minus 45 gets you 15. So I can start by saying, well, since I can't evaluate sine of 15 degrees, instead, let me evaluate sine of 60 minus 45. So we're choosing two numbers that we can evaluate, because then when we break it up according to the sum and difference, I will be able to break that up correctly or accordingly. All right, so sine of A minus B is equal to, so again, I'm using the A minus B for sine because I've got this minus sign right here, and I can go ahead and use the sum and difference. So sine A cosine B minus cosine A sine. All right, so 60 is A and 45 is B. So when I rewrite this, I'm going to use 60 for A, 45 for B. So sine 60 times cosine 45 minus cosine 60 sine 45. And this is subtraction. So I got to draw my 60-degree triangle. So that's root 3, 1, and 2. And I got to draw my 45-degree triangle. So that's 1, 1, root 2. All right, so I'm going to take this and evaluate it. So sine of 60. So you go to your 60-degree triangle and you do sine of 60, which is opposite over hypotenuse. Cosine of 45 is adjacent over hypotenuse. Cosine of 45, I'm sorry, I'm on angle A, so cosine of 60 is 1/2, and sine of 45 is 1 over root 2. All right, so we'll multiply, and then we'll subtract. So when I multiply, I get root 3 times 1, which is just root 3, and 2 root 2, minus 1, 2 root 2. Now the good thing is that we are going to just allow y'all to keep the radical in the denominator, so you don't have to worry about rationalizing in this unit. So we get root 3 minus 1 all over 2 root 2. And that's going to be a fine answer. If you want to rationalize, you can, but you're just going to cause more work than you really need to. All right, so for the remaining of these problems, so if you look at all the problems that I've given you, you say that's a lot of problems to do all those steps each time. But cosine 75. So I want you to really pay attention to everything that we've done. past couple of days. So yesterday we learned about cofunctions. And cofunctions are things that add up to 90. So when I think about 15 and 75, I automatically think about cofunctions. And I know that cosine of 75 is equivalent to sine of 15. So since I already found that answer, I can go ahead and just say, well, it must be that same answer. Root 3 minus 1 over 2 root 2. Cosecant of 15 degrees. Now, this isn't cofunction, but what is cosecant? So cosecant is the reciprocal of sine. So if I have the sine answer, then if I'm going to do the reciprocal of that, reciprocal means top goes to bottom, bottom goes to top. So the answer to this, without having to actually do the work again, is going to be 2 root 2 is on top, root 3 minus 1 is on bottom. And again, you do not have to rationalize. All right, and that's it for these notes.